All right, let's do 3.4, which is the chain rule. Here is the chain rule. This is a rule for doing the derivative of a composite function, which, if you remember, a composite function is like when we're doing f of g of x. And it has this formula. So we're going to do a bunch of derivatives using this formula. So I'm going to start slow. We are eventually going to build up our way to the point where we're very comfortable using the chain rule, and we're not going to have to break it down this much. But people naturally have a lot of trouble understanding composite functions. Once you get used to it, it's not that big of a deal, but I'm going to start slow on the first couple of these. I'm really going to break it down. This is f of g of x, where maybe it's easier to say what g of x is. G of x is the inside function, so I would say that g of x is the thing that we are raising to the fourth power. And then f of x is like going to represent what are we doing to that. What we're doing to that is raising it to the fourth power. So f of x is going to be x to the fourth power. And if you don't believe me, just imagine, like, based on what I've written down for f of x and g of x, just imagine plugging g of x into f of x, and this is exactly what you would get if you did f of g of x. So let's find the derivatives. F prime of x would be 4x cubed, right? G prime of x would be 3x squared plus 2, right? And then let me assemble my answer. It's f prime of g of x, meaning I'm going to take g of x and plug it in here. So let me write that. F prime of g of x would be 4x cubed plus 2x cubed, right? I put this in for x. So that's just this part. I still have g prime of x, so I'm going to multiply that by g prime of x, and there's nothing funny about this. I don't have to plug in anything special. It's just copying it down. And there we go. That's my answer. So we're eventually going to get to the point where we don't have to write down what f of x and g of x are every single time. That's what we're going to work our way towards. But I wanted to walk you through this one and really spell out what is the outside function. And by the way, f of x is the one that I call the outside function. It appears on the outside, and g is on the inside. So let's do another one like that. This one is really not too complicated. The reason why I'm doing this one mostly is because of this funny notational issue. When we write things like this, sine squared of x, like we put the power on top of the function. This can be confusing for the purposes of the chain rule, because for the chain rule we want to identify the inside function and the outside function. So let me write this in an equivalent way. What this actually means when I write a power here is that I'm going to do sine of x and then square that, meaning I'm doing sine of x times sine of x. So it's the same as this. I'm doing sine of x and then I'm squaring that. Writing it this way may make it more clear. And I'm going to break this down as well. Eventually, like I said, we're not going to break this down every single time. But this is only our second example, so I'm going to break this down. How do we want to think of this? One way of thinking of this is if you were to have to plug in a number to this, like what order would you push the buttons on your calculator? If I were to plug in a number to this function, the first thing I would have to do is to find the sine of x. Whatever that first thing is, that's your inside function. Whatever you do after that is on the outside. And what I would do after I found the sine of x is I would take that number and square it. So f of x is going to be x squared. And once again, you can imagine, if you don't believe me, just imagine doing f of g of x. That would mean I plug this function in for x, and I would get this. And then I do the derivatives. F prime of x is 2x. G prime of x is, if you remember our derivatives of trig functions, this is cosine x. And then I use the formula. I do f prime of, oops, pointing at the wrong thing. I do f prime of g of x, meaning I take g of x and I plug that in here. So that would give me 2 sine x, because I'm plugging this in here. So that's f prime of g of x, and I just need to multiply that by g prime of x, so I'm just going to take this and copy it down here. And that's it. That's the derivative. These parentheses aren't necessary, but whatever. Okay, let's do a third example, and for this one, let's not break it down all the way. I'm going to, maybe I'll say some things out loud that I won't write down, because I want to work our way up. This function is not terribly complicated to see. I would say the outside function is tangent and the inside function is cosine. So let's see if you can follow this. What I do is I do the derivative of the outside, but then I plug in the inside. The derivative of tangent is secant squared. If I was just doing tangent of x, then I would just write secant squared of x. But I'm not doing tangent of x, I'm doing tangent of this thing. So the derivative is going to be secant squared of this thing. So far, this is my f prime of g of x. I did the derivative of the outside function, and I plugged in the inside function. I still have to multiply by g prime of x, which would be the derivative of cosine, so negative sine x. And we can make this look a little bit nicer. As you can tell, I'm not so big on simplifying things, but let's say that's our answer. Okay. So let's start doing things that are more complicated. So for the next 3 examples, I have various derivatives that are going to involve a number of things. They might involve both the chain rule and the product rule, or it might be using the chain rule several times in the same example. So at this point, the list of our bag of tricks is growing. Our bag of tricks includes, we know how to do the derivative of powers of x and trig functions and exponential functions, and we have the product rule and the quotient rule and the chain rule, and that allows us to do a lot of combinations of things. But let's just start. So when I see something like this, the first thing I think about is what I call the big picture. Um, what I would say the big picture is here is that I'm doing the chain rule. If I just had e to the t, I would know how to do the derivative of that. Of course, I don't have e to the t. I have e to the some complicated other function. But that just means I'm going to have to use the chain rule. So the outside function would be like e to the t. So the derivative, of course, the derivative of e to the t is e to the t. But I'm not going to write just e to the t because I have to put this inside. So once again, I'm doing the chain rule. I did the derivative of the outside part, and now I just have to multiply by the derivative of the inside part. Like this is, I'm about to, so I've done this part, and now I have to do this part. And let me not even think about that right now. I'm not even going to think about what that derivative is right now. It is whatever it is. I'll figure it out later. So I'm slowly working my way towards the answer here. Now I will think about whatever the derivative of that is. So now I can sort of narrow down like what do I want to call my big picture now. I look at what I want the derivative of, and I see a product. I see t squared times something else. So I'm about to use the product rule. So how does this go? I'm going to do the derivative of t squared, and then I'll leave that alone. And then now I'm going to do t squared times the derivative of cosine 3t, which maybe, I don't even want to think about that right now. The derivative of cosine 3t, that's not something that I have memorized. That's not something that we have a preset formula for. So maybe I want to just worry about that later. Of course, it's not going to be much later. In fact, I have to worry about it in my next step. But I encourage you, for these problems that take several steps, I encourage you to do this type of thing where you, on the first step, I did the chain rule, and then I didn't even worry about the derivative of this thing. And then on the second step, I did the product rule just to start figuring out the derivative of this thing. But I didn't go all the way when I found that I had to do the derivative. When I found that I had to do something that I have to think about, I said, I'm not going to think about that right now. I'm going to think about that on the next step. Okay, but it's not going to actually be hard. So right now I'm just copying things down. Okay, now here's where I have to think. I don't really have to think that hard. This is just a simple chain rule. The outside function is cosine, the inside function is 3t. So derivative of cosine is negative sine. So I'll do negative sine of 3t, and then I have to multiply by the derivative of 3t, which is just 3. Right? And yeah, we could probably make this look a little bit nicer. I would like this negative sign to go out front. So yeah, but, well, okay. Here, I'll use I don't have that much space. I'm just going to make this a plus and make this a minus. This does not simplify very much, but I did want to move that minus sign there. Okay. So let's do another one. So this one is sort of, I mean, potentially confusing. I've got e to the sine t and sine of e to the t. So what would I describe as the big picture here? I see something times something else. So I'm going to use the product rule. How does the product rule go? Well, first I would do the derivative of one of them, and as you can tell, I'm not even going to think about what that derivative is. I'm literally writing down the derivative of whatever it is, without actually doing the derivative of whatever it is. And then I leave the other one alone. And then I'm going to have another term where I leave this one alone, and I do whatever the derivative of this one is. Now, of course, on the next step, I have to fill these in. This is a chain rule. The outside function is the exponential. It's the e to the t, and the inside function is sine of t. So to do this derivative, the derivative of e to the t is itself. So I'm going to start with e to the sine t. And then I have to multiply by the derivative of the inside, which is cosine t. So that's this part, and I still have to multiply it by this. And then I have to do this part, so I'll copy this down. And then, well, what is this? This is just a chain rule as well, except now the outside function is sine, and the inside function is e to the t. So the derivative of the outside is cosine. So I'm going to have cosine with the same inside, so cosine of e to the t, times the derivative of the inside. And the derivative of e to the t is e to the t. Right? And that is our answer. Okay, so then let's do one that is, this is probably the worst that I would ask you to do. So actually, let me rewrite this. Of course, cosine squared means I'm going to do the cosine of this and then square it. So that's the first thing I'm going to do. Also, I don't like square roots. I like 1/2 powers. So t e to the t plus t squared plus 1 to the 1/2 power, all to the 1/2 power, right? Because this 1/2 power is taking care of this square root, and this 1/2 power is taking care of this square root. Right? So that's the same thing. I just wrote it in a way that's more friendly for calculus. Okay, so what would the derivative be? I would take the derivative of the outside function. So the outside function it's like x squared, and the derivative of x squared is 2x. So I'm going to write 2x, except instead of x, I write the inside. This is a lot of writing. So it's the 2 times the cosine of that and then I would still have to multiply by the derivative of the inside. Yeah, I need more parentheses here. Right? And I can already tell I'm going to need another piece of paper. So we keep working. What do I have now? Now I would say the outside function is the cosine, and then the derivative of cosine is negative sine. So I'm going to have almost regretting making this example up because it's going to be pretty bad, but I am committed to finishing. So like I said, I just copied this one down. Now I'm doing the derivative of this one. The outside function is cosine. The derivative of that is negative sine. So I'm going to have negative sine of, let me make this a square bracket, negative sine of all this times the derivative of the inside. So, sorry to do this to you, but when I say the inside, that's what I mean. So I'm going to keep going. In fact, I don't want to keep writing all of this stuff down. This is the work that's still left to do. I still have to find the derivative of this part. So let me just work to the side. I'm just going to find the derivative of this part, and then for my final answer, I'll have to write it with all of this, but I don't want to write it over and over again. So what am I doing the derivative of? Again, it's this thing in the red circle. It's t e to the t plus t squared plus 1 to the 1/2 to the 1/2. I would say now that the outside function is this 1/2 power. The way I take the derivative of x to the 1/2 is I do 1/2 x to the minus 1/2. Except it's going to be 1/2 all of this to the minus 1/2. Times the derivative of the inside. Okay, so we're getting real close to done. In fact, I can probably do this in one more step, and then I'll have to assemble my answer. Let's do the derivative of this. Okay, this naturally has two parts, and I think we can knock out each part in one step. This is a product rule. This is a chain rule. So product rule here, the derivative of t is 1, and then I'll leave the e to the t alone. And then for the second part, I'll put t, and I'll leave e to the t alone, like that. So that's the derivative of that. And now I'm going to write the derivative of this. This is a simpler chain rule. The outside function is the 1/2 power. The inside function is this. So I'm going to write 1/2 times this to the negative 1/2. And then I still have to multiply by the derivative of the inside. The derivative of this inside is just 2t. Okay, and now I'm not going to do a whole lot to simplify this, but I am going to cancel the 1/2 and the 2 because that's easy enough. So like I said, well, it's probably good that I showed you a truly nightmarish problem. We got to apply several rules here. And so let's just assemble my final answer. All I had was I had 2 cosine of this times negative sine of the same thing, and then the derivative of the inside, which is all of that. So my final answer is just going to be this times all of this. And I will, because I was foolish enough to make up this problem, I will now painstakingly write down the final answer. 2. Actually, let me take this negative sign, like this negative, and I'll write it in front. So negative 2 cosine of this thing, t e to the t plus t squared plus 1 to the 1/2 to the 1/2 times the sine of the same thing times the derivative of the inside, which was all of this. So I'm going to write this on multiple lines. So this is times, so there's this 1/2, which can cancel this 2. So actually, let me get rid of that 2. And then I won't write this 1/2, and then I will write the rest of this. T e to the t plus t squared plus 1 to the 1/2 to the 1/2 times this, which is e to the t plus t e to the t plus t squared plus 1 to the minus 1/2. Yeah, so this may seem like an absolute nightmare, but this is just an example of a very complicated derivative that involves repeatedly using the chain rule and the product rule. There actually isn't one this bad on the online homework. It doesn't get this bad. But they do have slightly complicated ones. So I wanted to show you a complicated one. So there it is. But, you know, I still did it by hand. And I'm a human being, and I was able to do it. So it's not undoable. It's just maybe a bit more work than I would want to give you. Anyway,